Good morning to all. Myself, Dr. Arunagamia from Aerospace Engineering Department. Today, I am going to take one topic from fluid mechanics for aerospace engineering. So here, this uh, topic name is flow characteristics in fluid mechanics. So in that fluid characteristics, we will taken for the two approaches. One is for Eulerian, another one is for Lagrangians. So in that the fluid characteristic, there are the many characteristics are available in that fluid mechanics. So the first one is Eulerian. So in that Eulerian, it can be focuses on a fixed point in shape and tracks the properties of the fluid at those points as change over the time. Next one is by comparing this Lagrangian flow, individuals, fluid particles, and that trajectories as they move through this space. These are all the Lagrangians. So in that you see that flow characteristics. So in that flow characteristics, the generally the four characteristics. First one is velocity, streamline, streak lines, and path lines. So velocity fluid definitely it will be denoted the capital B, and streamlines the tangentials to velocity vector. So in that it will be so this the flow directions. Next one is the path line. So in that the path line for the fluid flow. Streak lines the fluid particles passes through the fixed point over the time. These are all the fluid characteristics of this one. Next one is the Eulerian approaches fixed in a space. So there are the four conditions, three conditions are available. First one is while observation point of view, the measure the fluid properties at fixed spatial local over the time. Next one is the flow analysis. You see that figure. So in that figure, the overall flow patterns and system behavior, you see that figure, the fluid flow, it will be comes by the segment by segment from top to bottom, 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 bottom. So in that flow, it will be move in that fixed area. So in that first it will be fixed in some particular distance. Second one is fixed in some particular distance. Another one is fixed in some particular distance. So for example, the water temperature it will be fixed in that river. So the in that Eulerian approach generally it can be used for the CFD, computational fluid dynamics. So that in that Eulerian approaches we can use this for the uh, fluid properties like velocity, pressure, and density. So the commonly this type of Eulerian approach used for the fluid flow, heat transfer, mass transfer problem in CFD analysis. So in that Eulerian can be used for the following properties for velocity V into X, Y, Z into time based on the time. Pressure P, density rho, temperature capital T. By comparing the Lagrangian approach, so in that Lagrangian approach, the individual fluid particles, it will be focused by this process, tracks the motion of the individual fluid particles, it will move through the space. So the commonly this type of Lagrangian approach used for the dynamics, mixing, and complex flow phenomena. These are all the so in that example, tracing the dye path injected into fluid flow. For example, if you apply the one particular chemical into the water, so in that chemical it will be spread over the water. So we will check the particular chemical will be spread over the water by using this Lagrangian approach. So by using this mathematical, so we will take for the individual study for the time. So by comparing the Euler approach, so we taken V into X comma Y comma Z comma T. So here we will the time it will be depend on the distance regions like X, Y, Z axis region. So that is called as particle positions. By particle velocity, it will be calculated by using this formula dx by dt, dy by dt, dz by dt. Acceleration will be taken a equal to dv by dt. So the differences, the Euler and Lagrangian. So the key differences for fixed spatial locations versus moving fluid in that frame references. So by focusing Euler, it will be overall flow fluid, it will be focusing. And Lagrangian, it can be useful to focus the individual particles. So that mathematical we will discuss it. So next one is advantages and disadvantages. So in that Eulerian advantages, the flow, continuous flow analysis is very easy, and steady state conditions problems we will sort out by using this approaches. Next one is drawbacks. The individual particles we are not able to track by using this Eulerian approach. Next one is the Lagrangians. By using this Lagrangians, each particles it will be monitored by using this approach. Difficulties by computational fluid dynamics, the Lagrangian particular part is very costly. So the time taken for this analysis is very far compared to the Lagrangian approach. So thank you. We will catch you on next topic on next session.